Okay, so follow-up on types of fractions would be some basic calculations of fractions. Please go make sure you know your difference between your types of fractions as well as your decimal fractions. Right, so in the previous video, I've already showed you how to convert, let's say, for instance, a mixed number to an improper, vice versa, as well as how to change a decimal to a normal improper, sorry, a proper fractional mixed number. So that has been covered. So if you're not too sure, rather go check that before we carry on here. So another property or calculation we have of fractions is changing it to equivalent fractions. So if you look at the word, equivalent fractions. So if you look at this phrase or word, the first thing that will ring a bell is kind of the word equal. So equal means it's the same, there's no value change. So if I give you the following, I've got a fraction 2 over 3 is the same as, equal as, let's say for instance, 10 over square, right? It's actually quite simple. You need to find a line where things are the same. So at the top line, I've got two values. I then ask myself, what do I do from the left to get to the right? And you can only times or divide. So what do you do with 2 to get to 10? You times by 5. And what you do at the bottom, you have to do at the top and vice versa. 3 times 5 is 15. And we leave it at that. If you then had to go the extra mile and then convert this back and say, okay, what number can go to 10 and 15? You'd say 5. You'd then be left with 2 over 3. If you carried on like that, we cannot guarantee your mark because then you've just supplied me the question, and that's not what I asked. I asked you to give me the equivalent fraction of the following. Next thing is comparing fractions. So just like I cannot compare apples to pears, I cannot compare fractions that do not have the same denominator. So we see this in tests where we ask you to write the smaller than, larger than, or equal. It's also when we ask you to put it in ascending order or descending order. We also actually compare fractions, and there are many other cases as well. So if I give you, for instance, two fractions, I give you 4 over 9 and 5 over 10. And I'll ask you to supply for me the smaller than, larger than, or equal sign. You cannot play guessing games. So we need to find a common denominator. So it goes back to my HCF and LCM lesson. In plain English, I'm trying to find a number that 9 and 10 can divide into. So a number that they can both fit into, that's quite easy off of the bat, is 90. Right. Now to do the following, I need to change both fractions so they speak the same language. So what do I do with 9 to get to 90? I times by 10. What I do at the bottom, I do at the top. So I'm going to times by 10. 4 times 10 is 40. To go from 10 to 90, I times by 9. What I do at the bottom, I also do at the top. Times by 9. 5 times 9 is then 45. Now, a lot of you argue and say, oh, but if you enumerate, you can just look at your numerators. You don't have to do this. But we're going to trick you like that because you cannot compare fractions solely on its numerators. You have to have a common denominator. So 40 is much smaller than 45. So therefore, it's smaller than 5 over 10, or rather 45 over 90. And that's how we compare two fractions. The next step we have, and I'll explain this more in the upcoming videos, is adding and subtracting of fractions, multiplying and dividing of fractions. And I'm going to do that of normal fractions as well as decimals, and those will be quite lengthy videos.